Hi chemists, my name is Kim and today we are going to be continuing our work naming organic compounds. Today we're going to be focusing on identifying a halide using table R, also sometimes pronounced halide, and sometimes also called alkyl halide. So given a structural formula, you should be able to, at the end of this video, identify the organic compound as a halide. You should also be able to do this if you're given the chemical formula or just the compound name. You should also be able to, if you are given just the structural formula of a halide, write its IUPAC name or identify its IUPAC name using table R. If we take a look at table R, we can see that the halide group is right there up at the top, and it's easily identifiable because it involves compounds that contain one of the group 7 elements. So if we have a halocarbon or a halide, and we're thinking about some of the characteristics of it, the most important one to note is that its functional group simply means that it contains a halogen that is a group 7 nonmetal. Specifically, you can see on table R, fluorine, chlorine, bromine, and iodine is bonded to somewhere either in the middle or the end of a carbon chain. There could be one halogen bonded in a halide, or there could be more than one. The general formula is Rx, where R is any group of bonded atoms and X is a group 7 halogen. So to name a halogen, a halide, or a halocarbon, you count the number of carbons in the parent chain, counting it so that the halogen is coming off of the smallest possible number. You count the number of total carbons in that chain and name that parent chain as if it was an alkane using table P. Use the number that the halogen branches off as the first number in the name and then a dash. And then for the prefix of the name, use the first 4 letters in table T. So fluoro, chloro, bromo, or iodo. And by table T, I mean table R. And for the suffix, or the second part of the name, just use the name of the alkane as you wrote it. If there happens to be more than one halogen coming off of your carbon chain, you can use more than one number to represent where there are the different halogens coming off. So for example, 2,2-dichloropropane would tell me that on the second carbon in the propane chain, there are actually 2 chlorines coming off of that carbon. Let's look at how the example is named. So I've got 2-chloropropane on table R as the example of the halide. That's telling me that there is a halogen coming off of carbon number 2 in the parent chain. And I'm going to have prop 3 carbons in that parent chain. So 1, 2, 3 carbons in my parent chain. I'm going to set it up like an alkane, except for that 2 is telling me what number the halogen is coming off of. Now, because it's propane and because it is a symmetrical molecule, I actually can number it either way, left to right or right to left, and I will still end up with the same structure because no matter what, the carbon in the middle is going to be carbon number 2. So off of carbon number 2 comes a chlorine atom, and that is how I can tell that I have 2-chloropropane. If chlorine was substituted for an F, I would have 2-fluoropropane. If it was a Br, I would have 2-bromopropane. If it was an I would have 2-iodopropane. Let's do a practice problem. So given the formula representing this compound, what would the IUPAC name be? This one is kind of tricky. Because there are 2 chlorines coming off of the second carbon from the right, the name of this would be 2,2-dichloroheptane. I didn't talk about the prefix di, tri, using the prefixes to go in front of the name of the halogens, but essentially you are putting a prefix there that will match how many numbers you wrote. So 2 numbers is di. This would be the type of problem that they would just be asking you to recognize the answer to on a Regents exam. They wouldn't ask you to write this question from scratch for yourself. But since there are 2 chlorines coming off of carbon number 2, Notice this is not carbon number 6. If I was numbering from left to right, I would think that maybe it was on carbon number 6, both of those chlorine atoms. But really, I want those to be on the lowest number carbon as possible, so I actually want to start numbering from the right and then go to the left. So 2,2-dichloroheptene tells me that I have a heptane chain. That's 7 carbons. And on the second carbon, I have 2 chlorines coming off of it. Final question for today. Identify the class of organic compounds to which the product of this reaction belongs. So this is a reaction between 2-methylpropene and hydrogen chloride gas. Notice this question is not asking you to name the compound. It's just asking you to identify what type or what class of organic compound does the product belong. So hopefully you notice the Cl up there attached to one of those carbons. This would be a halogen, a halocarbon, or sorry, a halocarbon or a halide because it has a halogen coming off of one of the carbons. This would be a little harder to name because it also involves a methyl group coming off of that same carbon, but just if you're curious, this would be 2-chloro, 2-methylpropane. Let's check back in on our learning goals. Hopefully you feel more comfortable identifying whether or not an organic compound would be classified as a halide using table R and naming halides based on their structural formula. Nice job today.